All right, what's up, AP Physics students? Another video on applying circular motion. We're going to be doing another problem in which we can see a real-life example of circular motion and apply our basic understanding of the characteristics and qualities of circular motion into a problem. So without further ado, let's get started. So let's get a problem in here. Okay, so we have a horizontal force. We have a horizontal force, or a horizontal force of 310 newtons acting on a 2.0 kilogram mass ball. Okay, a 2.0 kilogram mass ball. All right, and this ball is rotating uniformly, so the ball is in uniform circular motion. Ball in uniform circular motion, and it is in uniform circular motion, and this circular motion has a radius of 0.90 meters. All right, and they ask us, with this given information, to calculate the speed of the ball. So, as I said in all of my previous videos for physics, the first rule of physics is to try to draw a diagram of the problem. So we have this ball, and it is in uniform circular motion. In fact, it states it's in uniform circular motion, and it's traveling in a horizontal circle, not a vertical circle, a horizontal circle. So that's important. It's in horizontal uniform circular motion. So it's basically, if you can picture it, it's you twirling a lasso, or the cowboys, how they used to do it, over your head. It's going in that type of circular motion. So we can draw hopefully a decent picture, and you would have to, and this is not good. You'd have to make the implication that we're going in horizontal motion, but we need some sort of diagram, so you can look at it from a top view if you need to. But okay, we have a circle here. We have some sort of circle, and we know that we have a 2 kilogram mass ball. So we have a ball, and they give us its mass. Its mass is 2.0 kilograms. All right, so we kind of gave that information. And it's in uniform circular motion, and the radius, that means the distance from the center of the circle, they gave us to be 0.90 meters. All right, 0.90 meters. So we showed this information. Now, the third piece of information that they gave us is that there is a horizontal force of 310, let me double check, 310 newtons. All right, there is a horizontal force of 310 newtons. Now, if you're not sure where the horizontal force is, please do look at our previous video on the basic characteristics of circular motion, and you'll understand that horizontal, or any type of force acting on this ball, will be radially inward. All right, so there is a force, a horizontal force, and I will do this in a separate color. There is a horizontal force. There is a horizontal force of 310 newtons. So now they're asking us, with all this given information, to calculate the speed of the ball. So what can we do here? Well, we're given a horizontal force. So let's first use that piece of information. We know that any type of force that's acting on this ball is pretty much our net force, because it's radially inwards, right? So we can say that the summation of all the forces, or this is just another way to write F net, equals this 310 newtons. Okay, our net force acting on this ball is 310 newtons, because that's the horizontal force acting on the ball, and that is basically stating in circular motion with the basic characteristics we know that that will be our net force. So we can rewrite net force using Newton's second law that F net equals ma, and F net is nothing but the summation of all forces. All right? Using this basic principle of Newton's second law, we can rewrite this as the mass times the centripetal acceleration equals 310 newtons. All right? Mass times centripetal acceleration equals 310 newtons. And that kind of looks like a 6, so I will rewrite it. 310 newtons. All right. So what information can we possibly plug in to this derived equation to make it easier on ourselves? Because right now we have two variables, so we can't really solve for anything. Oh, wait. Yeah, they gave us the mass of the ball. It's 2.0 kilograms, and we have a mass variable here. So let's plug in that value. 2.0 kilograms is the mass of the ball. Do they give us our centripetal acceleration? No, they really don't. But can we find it? Yes, we can. How can we find it? Well, we use algebra and we divide both sides by 2.0 kilograms. 2.0 kilograms, and we get that our centripetal acceleration is equal to 310 over 2.0, which is 155 meters per second squared, right? 310 over 2 is 155 meters per second squared. But you're like, yeah, okay, we have centripetal acceleration. That's great, but they're asking us for the speed of the ball. We didn't really solve anything. Well, wait. We can use centripetal acceleration and solve for speed. How can we do that? Well, we know the equation of centripetal acceleration. We know that centripetal acceleration is equal to a tangential velocity squared over our radius, divided by our radius. We know that our centripetal acceleration, which we've just calculated from our derived equation, we know that our centripetal acceleration is 155 meters per second squared. And this should equal some sort of tangential velocity, which is essentially your speed, over a radius. Wait, did they even give us a radius? Let's see. Oh, right. Radius equals 0.90 meters. So let's plug that in, 0.90 meters. All right, they gave us our radius. So now we use algebra. We need to try to get our tangential velocity by itself because that's nothing but speed. So we multiply both sides by 0.90 meters. Multiply this side by 0.90 meters. And hopefully it's not getting too convoluted, not too much space to write all this. So 0.9 times 155 is equal to 139.5. And if we were to, if you wanted to, we have meters squared over seconds squared for that. So we have to take the square root of both sides. All right, take the square root of both sides, and the square root was not. All right, take the square root of both sides, and that gives us our tangential velocity because the square root of anything squared is just whatever is inside the square root. So we are given that our tangential velocity, and I will rewrite this. Our tangential velocity is equal to the square root of 139.5. And that's nothing but 11.81 meters per second. And you might say, well, we had meters squared and seconds squared. Remember, I just said that the square root of anything squared will just be meters and seconds. The squared and the square root will cancel out. So we're given a tangential velocity, and we've pretty much just solved for everything that we need.